Hello there, grade 9 math learners. I am here today to discuss to you one of the topic in this week's WLP, and that is graphing quadratic inequality. For today's lesson, I want you to prepare these following materials: graphing paper, ruler, ball pen, and highlighter. Basically, class, this lesson is just similar to our previous discussion, graphing quadratic function. So I want you to sit back, relax, and ready to listen the different examples. So let's have example number 1, grade 9. Graph the quadratic inequality by graphing method. Given y is greater than x squared minus 4x plus 4. So the first thing that you're going to do is change the inequality symbol to equal sign. Next, determine the opening of the parabola. You already know how to do this one because we already discussed this one with our previous topic. C, determine the vertex. Letter D, determine the x-intercepts. Determine the y-intercepts. Next, present the table of values with at least 5 points. Next, sketch and shade. And lastly, determine the minimum or the maximum point. Now, let's have our solutions. So, let's start with A. For A, you're going to change the inequality symbol. So, from y greater than x squared minus 4x plus 4, change the greater sign symbol to equal sign. So, it will become y equals x squared minus 4x plus 4. After that, letter B, we need to determine the opening of the parabola. So since our A is 1, our B is negative 4, and our C is 4, we already know that the parabola opens upward. Letter C, determine the vertex. In determining the vertex, class, you already know that you need to solve for the h and the k. So for the formula for h, by the way, you need to identify first your a, which is 1. We will write it again, negative 4, and z is 4. And the formula for our h is h equals to negative b over 2a, and for our k is 4ac minus b squared over 4a. So we need to substitute h minus or negative 4 over 2 times 1. And that's negative times negative 4, that is positive 4 over 2. 4 divided by 2, that is h equals to 2. Box your answer. Next, for k, substitute 4 times 1, your c is 4, your b is negative 4, squared it, all over 4 times 1. And that is 4 times 1 times 4, that is 16, minus negative 4 squared, that is also 16, over 4. And that would be 16 minus 16, that is 0, over 4, and the answer is 0. So the vertex here is, therefore, the vertex is 2, 0. Next, for letter D. For letter D, you need to identify the axis of symmetry. And we already know that the axis of symmetry is just equal to h, and our h is equals to 2. Therefore, our axis of symmetry is 2. Next, for E. For E, we're going to solve for the x-intercepts. For x-intercepts, class, we're going to let y be equal to 0. And from our quadratic equality, which is y equals x squared minus 4x plus 4, change y to 0, so it will become 0 equals x squared minus 4x plus 4. Then interchange x squared minus 4x plus 4 equals 0. You'll choose any of the method, either completing the square, factoring, quadratic formula, or extracting square root. So for this, I will choose factoring. Okay, square root of x squared, that is x. Copy minus square root of 4, that is 2. Therefore, it will become x minus 2 equals 0, and x minus 2 equals 0 by factor property of equality. Then it will become x equals 2, x equals 2. So they have the same answer. Therefore, the x-intercept here is 0, 2, 0. Okay? Next, let's move on to the y-intercepts. For y-intercepts, it is similar also for solving the x-intercepts, but this time we're going to let x be equal to 0. So the given quadratic inequality or quadratic equality, which is y equals x squared minus 4x plus 4, change or substitute 0 to all x, so it will become y equals 0 squared minus 4 times 0 plus 4. And that would be 0 minus 0 plus 4, and lastly, the final answer is 4. Therefore, our y-intercept, there will be only y-intercept this time. So our y-intercept is 0, and our y is 4. Now let us proceed to letter F, which is the table of values. For this class, you're going just to create the table and make sure it has at least five cells there. Okay, and on the center, you're going to write on the center the vertex, and our solved value for vertex is 2, 0. And put the 2, 0 here. Then we're going to continue consecutively with the numbering on x. Since we already know that these points here, class, 1 and 3 and 0 and 4, these are symmetrical points, we're just going to solve for 0 and 1. So we will let x be equal to 0 and get the quadratic equality of our given. Change x to 0, and 0 minus 0 plus 4, and the answer is 4. So our y here is 4, and the symmetrical point of these coordinate or this ordered pair is here, so it's also 4 here. Next, let x be equal to 1. So y equals x squared minus 4x plus 4. Y equals 1 squared minus 4 times 1 plus 4. Y equals 1 minus 4 plus 4, and the answer for that is 1. And you will just put 1 here, then the other one to its symmetrical point. And now we're going to proceed to letter H, which is sketch and graph. So this is what is new on this lesson. We need to sketch and shade the graph. Now let's start plotting points. So here we have from our table of values 0, 4. 0, 4 is in this one, and I want you to label. We need to make it bigger. 0, 4, and label 0, 4. Next would be 1, 1. 1, 1 is in this part and label 1, 1. Next, 2, 0 in this part, 2, 0. And next, 3, 1 here, 3, 1. And next would be 4, 4. So 4, 4 is in this part. Okay, before you connect the points, class, I want you to remember, go back on the given inequality, and the given inequality is this one. So y equals to y, I know y is greater than x squared minus 4x plus 4, and since the inequality there is greater than, so we're going to use the broken line. We're going to use the broken line in connecting the points. Okay, but if the given there is greater than or equal to or less than or equal to, then we're going to use the solid line. So since the given is there's no or equal to, then we're going to connect the lines, or we're going to connect the points using broken line. So connect using broken line and put still arrowheads. So as you can see, if we're going to make our graphing, our parabola bigger, it looks like this. Next, class, what you're going to do, you're going to pick one point from the inside of the parabola. So this time I'm going to get 2, 5. 1 point inside the parabola and 1 point outside the parabola. So 2, 5 for the inside, and I will pick 1 point from the outside, which is negative 3, 0 here. So why we need to pick a point? So that we will know what part of parabola are we going to shade. Okay? So let's have the checking. So we're going to use the original. So the inside point is 2, 5. Then it will become y greater than x squared minus 4x plus 4. We're going to test, class, if this will become true. So it will become 5. Substitute 5 greater than 2 squared minus 4 times 2 plus 4. So it will become 5 greater than 4 minus 8 plus 4. And 5 greater than 4 minus 8, that's negative 4 plus 4. And 5 greater than 0, which is true. Now we're going to test the outside point, which we have chosen, negative 3, 0. So we will use the original quadratic inequality y greater than x squared minus 4x plus 4. Change y to 0, since that is our inequality or the point that we have chosen, greater than negative 3 squared minus 4 times negative 3 plus 4. So 0 greater than negative 3 squared, that is 9. Negative 4 times negative 3, that's positive 12 plus 4. 0 greater than 9 plus 12, that is 21 plus 4, that is 25, which is our answer is false. So therefore, our true value is on the inside of the parabola. Then prepare your highlighter. We're going to shade now the inside of the parabola. So we will do the shading. So make sure that it will not be so messy. Color it properly, class. So from here, you're going to color that one using your highlighter. Then after highlighting, your parabola or the shaded part of your parabola should look like this. So you need to shade until the end of your graphing paper. Okay, now lastly, we need to determine the minimum and the maximum point for letter I. And this is very easy for us, and this is very easy for you because you already know how to determine the maximum or the minimum point. Okay, so since our parabola opens upward, then we have the minimum point. Our minimum point is 2, 0. And I need you to box your final answer. Okay, that's it for number 1. So before we end this number or this example, we will going to review the things that we have discussed. So first, again, you need to change the quadratic inequality to equality, change the symbol to equal sign. Then determine the opening of the parabola by knowing what is A. If A is greater than 1, then the parabola opens upward. Next, solve for the vertex using the HK formula and identify the axis of symmetry. Then, use or find the x-intercepts by letting y be equal to 0. Then use the method of extracting square root, factoring, completing the square or quadratic formula. Then find the y-intercepts rather by letting x be equal to 0. Next, you need to present the table of values by putting first the vertex at the center, then supplying the x or the domain consecutively with the numbers. Then you need to solve for the value of y. Next, you need to sketch and shade. You need to sketch the given points on the table of values, and you need to check again if the given inequality is in greater than or equal sign. Then you need to use the broken line, and if it is greater than or equal to or less than or equal to, you need to use the solid line in connecting the points. After which, you need to get 1 point from the inside of the parabola and 1 point from the outside. Then you need to check or you need to test. Whoever who has the true inequality, in that part you need to graph that parabola. Either it's inside or outside of the parabola. Next, then lastly, you need to determine the minimum or the maximum point. Okay, now let's have another example. So let's have example number 2, grade 9. Graph the quadratic inequality by graphing method. Given y is greater than or equal to -2, quantity x minus 1 squared. So still, the process is still the same. So for A, since the given is y is greater than or equal to -2 x minus 1 squared, you're going to change that 1 into equal sign, so it will become y equals -2 quantity x minus 1 squared. For letter B, determine the opening of the parabola. So you know that y equals -2 x minus 1 squared. The A there is -2, and since -2 is less than 0, therefore the parabola opens downward. It is easy for us to determine the vertex for letter C because the given is in vertex form. So the vertex form is y equals A x minus h squared plus k, and then the given here is y equals -2 x minus 1 squared. Therefore, the vertex or your h and k, the vertex is 1, 0. Why 0? Because there's no plus here, therefore the k is 0. So I want you to highlight that one. Letter D, we need to solve for the axis of symmetry. So we know that our axis of symmetry is equals to h, and h here, class, this is hk, so our h is equals to 1. Therefore, our axis of symmetry is 1. Now let's move on to x-intercepts. For x-intercepts, which is in the given, y equals negative 2x minus 1 squared. Therefore, you will let y be equal to 0 and change 0 equals negative 2x minus 1 squared. Exchange, position, arrange properly. Therefore, we could use this one extracting square root. So divided by negative 2 divided by negative 2, that would be x minus 1 squared. This would be cancelled, equals to 0. Extract square root, class, so that we could cancel the squared. So it will become x minus 1. Square root of 0 is 0. Then x equals to transpose negative 1, it will become 1. Therefore, our x-intercept here is 1, 0. Next, for the y-intercept. For y-intercept, we already know that to get the y-intercept, we will let x be equal to 0. So, y equals negative 2x minus 1 squared. Change x to 0. So, it will become y equals negative 2, 0 minus 1 squared. Y equals negative 2, negative 1 squared. So, it will become y equals negative 2, negative 1 squared is 1, so y is negative 2. Therefore, our y-intercept is 0, negative 2. Now, let's move on to letter F, the table of values. So, create a table, construct a table, and have it into 5, at least 5 values this time. And you put on the center your vertex, and our vertex is 1, 0. Put it here, 1, 0. Then write or supply x here, the values of x here consecutively, so it will become 2, 3, 0, negative 1. And we will we're going to solve now for the values of y. So we know that these points are symmetrical. Okay, so we will just solve. Let x be equal to negative 1. Use this equation. Y equals negative 2 x minus 1 squared. Change x to negative 1, so it will become negative 1 minus 1 squared. Y equals negative 2 squared, and negative 2 squared, that is positive 4. Y equals negative 8. So you're going to put negative 8 here in y. And since they are symmetrical, so negative 8 also here. Now let x be equal to 0. Y equals negative 2, 0 minus 1 squared. Y equals to negative 2, 0 minus 1 is negative 1 squared. So y equals to negative 2, 1. Y equals to negative 2. So the answer here is negative 2. And since they are symmetrical, negative 2 also here. And the next process is we're going to sketch and shade. So using the table of values, we're going to plot now the points. So let's start with negative 1, 8. So negative 1, negative 8 is in this part. Then I want you to label negative 1, negative 8. Next point is 0, 2, 0, negative 2, so it's here. I want you to label as well 0, negative 2. Next, the vertex is 1, 0. Then label 1, 0. Next is 2, negative 2 here. And lastly would be 3, negative 8. As I am discussing to you, class, that if the given, you go back to the given inequality. If the given is greater or less than, you're going to use broken line. But if the given is greater than or equal to or less than or equal to, you will use solid line. And in this example, the given is in the greater than or equal to. Therefore, we're going to connect the points using solid line. So, connect the points and continue until the end of the graph, then put arrowheads. After which, class, after connecting all the points or creating your parabola, you need to make or you need to create or you need to choose a testing point. So, you need to choose one testing point inside the parabola. So, in this case, I will choose 1, negative 3 inside the parabola and 1, 1 outside the parabola. Okay, so you can choose any of the points inside and any of the points outside the parabola. And then we need to check. So it is very important that we will check so that we will know what part of the parabola are we going to shade. So let's have first the inside point. And we have chosen 1, negative 3. Use the original inequality, which is y greater than or equal to negative 2x minus 1 squared. And your y is negative 3. Substitute greater than or equal to negative 2. Change x to 1 minus 1 squared. So negative 3 greater than or equal to negative 2. 1 minus 1 is 0 squared. So negative 3 greater than or equal to negative 2 times 0, which is negative 3 greater than or equal to negative 2 times 0 is 0, and negative 3 greater than or equal to 0, that is false. Now let us check the outside point. So y greater than or equal to negative 2x minus 1 squared. Our y is 0. Greater than or equal to negative 2, 1 minus 1 squared. 0. Greater than or equal to negative 2, 1 minus 1, that is 0 squared, and all still the same. Negative 2 times 0, that is 0. So 0 greater than or equal to 0, the answer is true. So as you can see, class, since the outside point tests true on this checking, then we need to highlight the outside points. So from this part of the parabola, I want you to use your highlighter and highlight all the points or all the space outside the parabola. Slowly but surely. And that's it, class. You need to shade all the outside region of the parabola. Lastly, we're going to have the minimum or the maximum point. Since our parabola opens upward, we only have the maximum point. And our maximum point is 1, 0. Then I want you to box your answer. Okay, and that would be the end for example number 2. Before I let you go, we need to review first from the beginning. Okay? So given the inequality y greater than or equal to negative 2x minus 1 squared, change the inequality to equal sign, determine the opening of the parabola, find the vertex, and since this is already in the vertex form, we easily identify the vertex coordinates, axis of symmetry, x-intercepts, y-intercept, then the table of values, then we're going to sketch and shade. So we use the solid line since the given inequality is greater than or equal to. Then we get 1 point from the inside and 1 point of the outside of the parabola. Then we test, and which of them is true, we shade it. The whole region of it, we need to shade it. And lastly, identify the maximum point. That's all for now, mathematicians. I hope you have learned something for today. Thank you and God bless.